Hello everyone, hope everyone is doing well. In this video, we're going to look at a flowchart to figure out which test, what kind of hypothesis test we're dealing with and what kind of analysis should we do. So let's say we're given a question and we're asked what to do with it. So now if the question has, let's say, any kind of word like, let's say change, like we're testing if the population average has changed or something, then we are dealing with the two-tailed test. But if the question is saying increase or decrease, then we're dealing with the one-tailed test. Okay, now if we have a one-tailed test or two-tailed test, actually let me just write this in a nicer way. Now, in two-tailed tests, we don't have to deal with left or right tails, but in one-tailed test, if we want to show that whether the population mean has increased or decreased, so if it says increase or if it says decrease, then we will say if it's an increase, then we mean that it is in the right side. Is if our t-stat falls in the right side, then that means we are going to reject the null. So this will be a right tail test. But if it says decrease, then it will be a left tail test, which means that in our case, then the hypothesis testing would be in a two-tail test, it's h naught is mu equals some number, and the alternate is mu is not equal to some number. In a right tail test, we will say the hypothesis is going to be mu is less than or equal to some number, and the alternate is mu is going to be greater than some number. In the left tail test, we would be doing the opposite. Mu is going to be greater than or equal to some number, and the alternate is going to be mu is less than some number. And now, after we find our left tail and right tail, after we wrote down our hypothesis, the next step is basically going to be collecting the data. Now, when we have the data, now we have again two things. If sigma is known and sigma is unknown. Same thing here. We have if sigma is known and if sigma is unknown. So if sigma is known, we are using the z-stat. If sigma is unknown, we're using the t-stat. Same thing here. If sigma is known, we're using the z-stat. And if sigma is unknown, we're using the t-stat. For left tail test 2, we are doing the same thing. I will move this actually down here. Sigma known and sigma unknown. So once we have the numbers, if we calculate our t-stat and z-stat, then the formulas we would use in our... So then, this shows us the formulas for the finding the critical values. So for one tail test, we don't divide the alpha over with 2. Now, in the right tail test, since our distribution is we're testing that it's on the right-hand side. So basically, since it is going to be on this side, so that's why we put a negative side in front of our formula. Same thing here. We can either use this formula or we can use the t.inv.rt. That will give us this formula. In the left tail test, we are actually doing the other thing. So in the left tail test, we are actually finding it out of the other side, which is right here. And since all the formulas find it from the left to right in Excel, so we are fine not putting a negative sign in front. And for our case, the z-stat, it's going to be plus minus of this value. So basically this value, the two critical side values will be plus minus the value we get here and the plus minus value we get here. This is what we do here. And then finally, we can find if we can just drop the negative value, but if you want to, you can actually test it this way. So if this is my critical value, if my z-stat or t-stat is here, then we reject the null. If it's on this side, then if my z-stat is here, or t-stat is here, then we do not reject. I'll also write a t here. This is for the left tail test. Now for the right tail test, if that's my critical value, then if my z-stat or t-stat is basically on this side, then here we reject then here we do not reject. But if it is on this side, then if my t or z-stat is here, then we reject. Now for a two-tailed test, we would have two critical values, one to the left and one to the right. So if this is my distribution, one would be here, either the t or the z critical value, it would be the -1, and the t or the z critical value right here, and this would be the +1. So in our case, these are how we, it could be either from this formula or this formula. Now, if my z-stat falls anywhere here, we then do not reject our null hypothesis. But if it falls anywhere here or here, then we reject. And then finally, we then write our analysis.